Hello and welcome. If you're a data scientist who's serious about leveling up into MLOps, there's one tool you absolutely have to master, and that's Git. Today we're going to talk about how you can use it to go from that feeling of project chaos to having total MLOps control. Let's dive right in.
Oh boy, does this look familiar to you? I mean, come on, we've all been there, right? That project folder that's just overflowing with files that look like this. You have no idea what the real final version is or what changed between version 2 and version 3. It's pure chaos, and it makes your work almost impossible to reproduce.
So, I gotta ask, are you tired of this mess? If you're nodding your head yes right now, then you are ready. You're ready to embrace the system that brings order, power, and frankly, sanity back to your projects. So here's our game plan. We'll start with the why. Why Git is really the engine behind MLOps. Then, we'll get practical and walk through the essential commands you'll use every day. We'll talk about the crucial discipline of what to save and, just as importantly, what not to. And we'll wrap up with a pro strategy for collaboration, branching. Okay, let's start with that big picture. Why is Git so foundational for MLOps? Because it's the tool that takes your project from just a messy folder of files and transforms it into a system that's governed, reproducible, and ready for automation. This is a huge mental shift for a data scientist moving into an engineering role. So what is Git really? At its heart, it's a version control system. But don't think of it as just a tool for software developers. For you, the data scientist, it's your project's time machine. It tracks every single change to your code, your configs, your notes, giving you a perfect, undeniable history of your work. And that history leads us to the first pillar of solid MLOps, reproducibility. This is huge. By versioning your scripts, your config files, and all your hyperparameters, you can lock in the exact state of any experiment. That means you, or anyone on your team, can jump back to a specific commit and get the exact same result. Your work is no longer a one-off, it's scientifically sound. Next up, collaboration. You know, MLOps is a team sport. You've got data scientists, ML engineers, maybe some DevOps folks all in the mix. Git provides the structure that lets everybody work on their own piece of the puzzle, their own feature or experiment, at the same time without accidentally breaking each other's work. This brings us to a benefit that you'll be so thankful for later, traceability. Just imagine your model's accuracy suddenly tanks. Where do you even start? Well, with Git, you have a perfect audit trail. You can see every single change, who made it, when they made it, and, if they wrote a good commit message, why they made it. It's an absolute lifesaver for debugging. And finally, we get to the pillar that really unlocks the magic of MLOps, automation. This is where your Git repository becomes what we call the single source of truth. A simple command, git push, can kick off your entire automated pipeline. It can run tests, validate data, retrain a model, and even deploy it. That's the core idea of GitOps, and it's how you build seriously robust ML systems. Okay, so that's the why. You get it. Now let's get our hands dirty with the how. We're going to walk through the essential Git workflow. This is the simple rhythm you'll use day in and day out, and it's much easier than you might think. This four-step dance is the heart of it all. First, Git init just starts the tracking in your project. Then, Git add is how you tell Git, hey, I want these specific files included in my next save point. Think of it like putting files in a box to be shipped. Git status lets you peek inside the box to see what's there. And finally, Git commit seals that box and puts it on the timeline. Forever. Now about that commit. This is so important. Please, don't just write updated script. That tells nobody anything. Explain the why. What were you trying to fix? What was the new hypothesis you were testing? A clear message is like a note to your future self. And trust me, you'll be grateful you wrote it. Okay, you know the workflow. Now let's talk about discipline. A clean, professional repository is a happy repository. And that all starts with knowing what belongs in Git and what absolutely positively does not. Think of this table as your ultimate guide. On the left, this is the stuff you do commit. Your Python source code, your YAML config files, your documentation. Basically, the recipe for your project. But the stuff on the right is just as important. You never, ever commit secrets like API keys or passwords. And you don't commit huge files like raw datasets or trained models. That's just not what Git is for. It makes the whole project bloated and slow. So how do you make sure you don't accidentally commit the wrong stuff? You don't have to rely on memory. Use a file called .gitignore. It's just a simple text file that lives in your project, and it's a list of all the files and folders you want Git to completely ignore. It's like a bouncer for your repository, and you just set it up once and forget about it.
So what do you do with all that stuff you're not supposed to commit? Well, there are pro-level solutions for each. For secrets, you use environment variables or a dedicated secrets manager. For those huge datasets and models, you use something called GitLFS, which stands for Large File Storage. It cleverly tracks a tiny pointer file instead of the actual huge file. And a quick pro tip, if you need to track an empty folder, Git won't do it by default. So just put an empty file called .gitkeep inside it.
All right, you've got the basics down cold. Let's level up and talk about a strategy that is absolutely essential for working on a team and for running experiments safely. Let's talk about branching.
The most common way to do this is called feature branching. The idea is brilliant in its simplicity. You have one branch, usually called main, that is sacred. It's your stable, working, production-ready code. Any new work you do, a new feature, a bug fix, or a new model experiment, happens on a completely separate temporary branch. This keeps your experiments isolated and protects your stable code base from breaking.
So the flow looks like this. You always start from the stable main branch. Then you create your own new branch and give it a descriptive name, like experiment with new optimizer. You do all your coding and experimentation there. When you think it's done and working, you open what's called a pull request. This is basically you saying, "Hey team, my work is ready for review." It's a formal process where teammates can check your code and automated tests can run before anything gets merged back into main.
And this is where it all clicks into place. This disciplined branching flow ensures that only high-quality, reviewed, and tested work ever makes it back into your main branch. And because that main branch is so stable and reliable, it can now act as that source of truth that confidently kicks off all your automated MLOps pipelines. See how it all connects? So I'll leave you with this final thought to chew on. Your code is now versioned, and that's fantastic. But is your entire ML workflow versioned? The true power of MLOps comes when you version everything, your data, your models, your pipelines. And Git is the tool that makes all of that possible. That's all for this explainer.